Hello students, welcome to our channel. And for this session, we will be talking all about Pearson's correlation coefficient. And in this lesson, you will learn how to use Pearson's correlation coefficient to measure the strength and relationship between two variables. For example, you want to determine whether there is a significant relationship between the number of hours spent studying and your math final score, or if there is a significant relationship between your anxiety level in mathematics and your academic performance. So let's start the topic by defining what is meant by correlation. Correlation is used to describe and test the significance of relationships between two quantitative and continuous variables. How about Pearson's correlation coefficient? It is usually denoted as R, and it is a single number that gives an accurate measurement of how closely one variable is related to another variable. Moreover, it measures the strength of the linear relationship between two variables. Also, it is used to determine if a significant linear relationship exists between the variables. And it can be solved using the formula R equals this one. So take time to write the formula. So later on, we will be getting all the summations, the summation of x, the summation of y, the summation of xy, the summation of x squared, and the summation of y squared to get the value of R. Now, n here is the sample size, the number of the respondents, or the number of samples. You have to remember, the value can be between -1 and 1 inclusive. So all the numbers that are between -1 and 1 can be an answer. For example, -0.32, -0.97, or 0.97, as long as the value is between -1 and 1. Also, a positive R value indicates positive linear correlation. Also, a negative R value indicates negative linear correlation. Also, a 0 R value indicates that there is no linear correlation. And a -1 or a +1 indicate a perfect correlation. Also, the closer the value of R to 1 or -1, the stronger the relationship between the variables. So let's try to discuss first the positive and the negative correlation. Positive correlation, for example, you're trying to compare or you're trying to know if there is a significant relationship between your scores in algebra and your scores in trigonometry. Look at the values. As you can see, as the value of x increases, the value of y also increases. And that is positive correlation. So that means as the variable x increases, the y variable also increases. And that is a positive correlation. Meanwhile, a negative correlation looks like this. As you can see, as the variable x here increases, the variable y decreases. So it's an indirect effect. So we can say that as a variable x increases, the y variable also decreases, and that is a negative correlation. All right. So here's the table showing the verbal description of the strength of the correlation between two variables. So we have here the value of R, here are the range or the interval of values. And here is the verbal description for each. So take time to copy the following, as we will be using this in our lesson in interpreting the value of R. Alright, for example, a guidance counselor is interested in determining the relationship between the number of hours students spent on studying the math final exam and their obtained final exam scores. She selected a random sample of 8 students in a math class. The scores obtained by these students are shown in the table on the next slide. What is the Pearson sample correlation coefficient? So here's the scores of 8 students, and here is the number of hours. So we have here X is the number of hours spent in studying, and Y is their final exam score. So let's try to see whether there is a significant relationship between the number of hours spent in studying and their final exam score. So earlier, I told you that we will be getting all the summations. First, the summation of X. So in that case, we have to add all the values here, and we will have 20. The summation of X is equal to 20. Also, the summation of Y. So we have to add everything here, and we have 673, and that's the summation of Y. Also, we have the next column, we have xy. So that means we have to multiply all the values here and the values here. So we have 0 times 65, we have 0. 3 times 85, we have 255, and so on and so forth. Just multiply the values here and the values here. And after which we have to get the summation. So add everything, and we will have 1,805. Also, we have the next column, we have x squared. So we have to square the values under column x. So 0 squared is equal to 0. 3 squared is equal to 9. 2 squared is equal to 4, and so on and so forth. Now, we have to get also the summation. So add all the values. We have 68. And for the last column, we have the y squared. So we have to square the values under y column. So what is 65 squared? We have 4,225. We also have 85 squared. We have, all right, 7,225, and so on and so forth. And now we have to get all the sum. So add everything, and we will have 57,589. So now let's get the value of R using this formula. So our n, the sample size is 8, or 8 students. The summation of xy is 1,805. We have also the summation of x, which is 20. The summation of y, which is 673. So n also is 8 here. Then the summation of x squared, this one, is 68. And the summation of x, we have 20. We also have n here is equal to 8. Then the summation of y squared is 57,589. And we also have the summation of y. We have 673. So now let's start um, answering this or solving this. So first, multiply 8 and 1,805, and you will have 14,440. Also, multiply 20 and 673, and you will have 13,460. Also, we have 8 and 68. Multiply them. We have 544. And square 20. 20 times 20 or 20 squared is equal to 400. Also, multiply 8 and then 57,589. You will have 460,712. And then square also 673. And we will have 452,929. So let's now proceed. If you're going to subtract these two numbers, you will have 980. Also subtract the values here, 544 and 400, you will have 144. And then the two values here, if they are subtracted, we will have 7,783. So now, we multiply 144 and 7,783. But before that, we have to copy first 980 in our numerator. And then multiply the values in the denominator. So we have 1,120,752. And that is equal to 0.93. Now, if you're going to go back to our table earlier, where is it? That's 0.93. It's here. That can be described as very strong positive correlation. All right. Oh, all right. So since the value of r is positive and close to 1, the variables have a very strong positive correlation. It means that students who took more R's in studying get higher math score. Thank you.